Hello, everyone. Thanks for having me. As I mentioned before, I'm very happy to be the part of this Flutter week, and today we will talk about GraphQL and the GraphQL ecosystem inside the Flutter. My name is Vasili. I'm working in company 90% of everything, and we are revolutionizing the shipping industry. I started the front-end programming 6 years ago, lately added the React, and the last 2 years I'm working with React Native. This is one of the things that made me the Flutter enthusiast. Now I'm trying to launch first applications inside our company using Flutter. What drives me personally in the Flutter ecosystem is the Flutter show, which Google presents to us. I do not remember from my career previously any other frameworks that have so much adoption, so much spread from the first day of its release. The second thing that I assume everyone loves in Flutter is the experience that it gives us. It's a documentation, awesome docs, pixel perfect rendering, which made me crazy happy. So I do not need to fix the layout issues in Android or iOS like previously in React Native. The next two on the fast development cycle and the rich customizable set of widgets helped me to finish the mock in just 1 day. So I turned the design mocks for the application into a real application in just 1 day during my speed coding session. And it supports Android, OS, and iOS, and many other platforms, and also the one code base. You just run and it works smooth and fine. And the third thing is the IDE support. I can choose, and everyone can choose from either enterprise IntelliJ IDEA through free Android Studio to the lightweight VS Code. And this is pretty awesome. But at the end of the show begins the behind-the-scene life. And we need to brace ourselves because a lot of questions are coming our way. So as far as Flutter is pretty young, there are a lot of these questions. How to manage state correctly, how to make internationalization without a headache, how to communicate, what are the best practices, and so on and so forth. Today, I would like to pay attention about talking to the backend. What options do we have generally? The old and well-known REST API, which presented with a DO library. It's just some kind of Axios from, it's the same as Axios in the JavaScript world. We have a lot of libraries which supports WebSockets for. We have the gRPC library from Google initially. And the last one, we have the Flutter GraphQL library, which supports Flutter. Today, I will stop at the GraphQL because it's very promising, young, and good case to talk to backend. GraphQL was presented or open sourced via Facebook, and it is a query language for the API, and also the server-side runtime for executing queries by using the type system that you define for your data. So you need to know before start that GraphQL isn't made for any data storage. It is data storage agnostic and transport agnostic query language. A little bit of history. Then 2012, the initial development started, and 3 years later, Facebook open sourced the preview. the technical preview. It was so popular and widely adopted that only in 1 year we've got the production-ready specs and reference implementation. And the last step was in 2018 when they finalized the subscription specs. So nowadays we have the pretty stable environment which doesn't change very much, so it's production ready for now. For those who are interested in more in GraphQL history, I'd like to recommend the GraphQL documentary made by Honeypot. It's very interesting with those three guys, the fathers of the GraphQL, as I can say. Let's continue. Why developers love GraphQL? Actually, not everyone, but still a lot, I assume. GraphQL gives us a clean and concise schema definition language. So while you're developing your backend, you will have naturally this schema which describes all the data structure and all the types to the last bit. Just for comparison, here I have the JSON schema for REST definitions, which I took from documentation. And on the right side, you can see the same representation in schema definition language from GraphQL. It's pretty concise, small, and clear, and easy to understand. The GraphQL solves the under and overfetching issues which can occur in the REST world. The example of underfetching could be that you need to make additional network queries to render the single view when you do not get all the data you need in one round trip. And the overfetching is when you get too much data on your request. So for example, you need just a single Boolean field, and but you're getting instead hundreds of bytes useless information. Due to the query language, you can specify just the precise amount of data that you need. As you can see the demo on this video. Also, GraphQL helps to solve the versioning. As you know, during life cycle of the application, you can see the REST versioning, like REST API version 1, 2, and 3. And for example, the first version of GitHub API is made with GraphQL. So in case of GraphQL, you just add the required objects and queries and mutations that you need, and you do not worry with the overfetching problem. Introspection and types. As far as we have the schema, every GraphQL backend supports introspection queries, which returns you the full schema, and you can see all the types, all the structure of the query. So this helps a lot in understanding the capabilities of the backend, and also helps to make the great tooling for code completion and code generation. And also through the whole history of GraphQL, there are a lot of tooling for this. For example, the orange one logo is the Facebook Relay, the JavaScript client. For working with GraphQL, the Apollo is the alternative JavaScript engine. We have the GraphQL code generator, which helps with types a lot, and also the GraphQL faker, which helps us to mock and fake the GraphQL endpoints while the backend is not ready yet. Okay, so with all the benefits of the GraphQL, as you know, there is no silver bullet. we also have a little bit of issues to figure out, or pains. It's the client-side caching and validation. If you worked with GraphQL, for example, every GraphQL library implements some kind of client-side caching. As far as GraphQL doesn't utilize the default HTTP caching mechanism, and also you have some kind of backend challenges because GraphQL is not mapped directly to any storage, so your backend developers should figure out how to make the backend fast and performant in case if you have deeply nested queries, for example, or the one way to fix this could be named queries, which is supported by to GraphQL. It is some kind of REST, but in GraphQL world. For example, if you have the heavy query, which requires the precise SQL implementation, you can implement this like named query and call the query by name, and it will help you to meet the performance issues. And returning back to the error handling, if you saw the GraphQL org, there is a best practices section. So it covers the authentication and pagination, but there is no anything recommended about error handling. So you just need to personally figure out what is the best possible solution for you. Next. With all this being said, you could have a question: is REST API still good? Technically, yes, because REST API gives us extremely low data transfer. This results when you write your GraphQL queries, you get the precise amount of data that you need. The precise data amount of data that you need. This lowers the data rates a lot, but you also sending the little post body with the definition of the data, with the shape of your data that you want to retrieve. In case if you care about the last bit, the GraphQL endpoint is the shortest. The REST endpoint is the shortest solution. It utilizes the outcoming connection. We have also the Open API initiative, which promoted by Swagger, which specifies how the REST API should be built and the schema definitions for the API. In the REST world, we also hate the HATOAS. It's some kind of a standard giving the additional information about your REST endpoints. So with the default REST response, you are getting the links array, which describes other actions that you can perform with this object. For example, if you have the product, it could have the links to add to cart endpoints, remove from cart, and so on and so forth. So you can make with HATOAS some kind of schema or your REST discovery, and also it is useful in case of permission controls. There also a lot of tooling expertise was developed during the REST era. If you have a little amount of time and your team is experienced, mostly in REST, it could be also the case. Also, REST uses and utilizes the default caching mechanism and error codes, which helps a lot in routine CRUD operations. With all information that we know now about GraphQL, about its benefits, let's think about what we dream to have and how we would like the flow to look. First of all, if we have types and schemas, we would like to generate Dart types and classes, which covers our GraphQL API. We would like also to have the mechanism to automatically update our GraphQL schema with support of autocomplete and validation for GraphQL queries. And as a bonus, it will be great to have the possibility to mock API, to extend your backend API while some queries or mutations are not ready yet. Everything is possible. So we need for this the Android Studio or Visual Studio Code. For Android Studio, there is a JS GraphQL plugin which supports schema fetching and autocompletion, and Prisma for Visual Studio Code. And the last three items is libraries, GraphQL Flutter for making requests, Artemis for code generation, and GraphQL Faker is the last bit, which helps us in the today demo to mock the API. So talk is cheap. I would like to show you some code, how this works, how this whole bunch of plugins work together. First of all, we need to start our faked GraphQL server. So we just type GraphQL Faker. We pass the file name, which we would like to save the results, fake schema. And the last, we will ask to open the editor for us. Here, as you can see, we opened the editor. This is the amount of queries which is bundled as a default with GraphQL Faker. So we just make one change and hit save. So this file will appear in our IDE. So it's just this file. You edit and save, and you can commit it to your repository to share with your team. Second bit is we need the JS GraphQL plugin to fetch our schema. Here is our schema, just the same, but without the faking declarations. All companies, company and employee. We will work today on, we'll demo today on the companies. The third step will be creating our first query. We'll call all companies data.graphql. If we try to make any changes, we will see that companies data. We'll see that we have the awesome auto-completion. We will fetch for our needs the ID and name. This is pretty enough for our today's demo. Oh, sorry. Yeah. We will query the all companies data, and we will fetch ID and name for this. The next we will need is to use the Artemis library to generate the actual types. So we will run this command from our console and wait a little bit while Artem is doing his job. It's generating and generating. And we have success. Here are the 3 files that represent all the generated stuff that we need. So now we are ready to make some code. We'll start from the simple query. Pass there some options, the watch query options. We will pass there the document node, which we also have the generated one. All companies query dot document. Companies query dot document. And the last thing that we need is the builder function, which sets the result of the query. Let's mark it with result, and the second is refresh and fetch more functions. So all the query stuff is ready, and now we will implement the general flow of the GraphQL ecosystem. So first of all, we will check if we have any errors. Result has exception, and we return text with result exception string. If there is no data, and the state is loading, we will just return the circular progress indicator. Let's center it with help of awesome IDE. And the last one, we will return the list view builder. So here comes a little bit of magic with help of code generation. So we'll add the all companies variable. And we will use the from JSON parsers or deserializers, which are provided by Artemis library. We will pass the result and data and select all companies from here. So now we have in all companies, we have all the data we need, all the data from our query. It's typed, it's fully typed and supports auto-completion. So we pass the items count as easy as all companies lengths, and the builder is function with context and index. Return simple list title for our demo purposes with title equal to the name of the company. Text. All companies index dot name is the name that we fetched, that we defined in our GraphQL file. So that's all. And we are ready to launch our simulator. I will make it a little bit larger. This is very strange. The last one try, and I will continue. So just believe me, it works, because I tried it today several times. Nothing happens. Okay. We can also wrap the widget with refresh indicator and pass this on refresh the fetch. So as easy as you see. And the last thing which I would like to show you, and which covers all the presented tooling for you, is if we change the request. For example, we remove the name and regenerate the types. Let's wait a little. Okay, so we regenerated the types and we see immediately the errors there. We removed the name from the query, regenerated the types, and we will see that name is missing. So this shows up how all this tooling helps us to make a pretty good solution that helps us with auto-completion for our queries and for the schema, with awesome code generation. And as a result of code generation, we have the awesome error highlights in case of changes, or in case if your backend shipped the new schema and maybe change something or remove something, you will always be able to check whether it's an errors in your queries. And after regenerating types, you will see immediately what is there. So with power of GraphQL, we can make our code and our development process fast and reliable. So let's back to the last slide of the presentation. The last slide is the link to the GitHub repo, which includes all the code and a little bit more. Because today I added to the repository the demo of how to work with block pattern. So definitely visit it. It would take a pretty decent amount of time to make a live coding for the session. So I left the extended sample in our repository. So I hope you enjoyed, and support the community, support the GraphQL with pull requests or just a star. It's a pretty awesome libraries, which I mentioned today, the Artemis and GraphQL Faker and GraphQL Flutter. Thanks. Ready for the questions. So the first question, how to securely use API keys in a Flutter app, especially when one doesn't have a backend and just have to make the few API calls. Doesn't have the backend. So I'm not sure that I understood your question correct, because you will always need the backend for GraphQL queries, and the API case will not be exposed. So let's continue. Is there an easy way to dynamically generate the GraphQL query that we need at one moment. Is using a generated string the only way? You can write any generator that you need, but if you need to generate the GraphQL query on the way during the, for example, if you're selecting some filters or so, you can do this. I didn't looked for some kind of tooling for this. It's just making some JSON and serializing this JSON into string. So the usage of generated string for now is the simplest way. Next one. Yeah, as I mentioned, can you do the WebSocket subscription? Here is the next question. So GraphQL supports the subscription, and in 2018 the subscription was finalized. The subscription draft was finalized. In case of properly step of your backend, which requires a little bit to support the WebSockets, the Flutter GraphQL library supports the subscription, so with ease. Next, please. On the backend, I saw some. I didn't work with geospatial queries, so I saw some kind of tooling that helps to map the MongoDB on your GraphQL schema. Not much information I can give you about this. Next, please. Yeah, the Dart implementation, as stated in the README file, supports the implementation of two-directional stream requests via WebSockets. I think I answered this question several questions ago. Next one. No, I didn't write the FaunaDB, but I assume if it maps directly, it will be a good solution. I will try definitely. Thanks. Next. How do you see Firebase versus GraphQL? So they could not be compared directly because Firebase it's more than the GraphQL is the protocol to talk to the backend, and the Firebase is some kind of all-in-one solution. So it's widely used to speed up the MVP, allows authentication, and so on and so forth. So the GraphQL could be used in the Firebase, but from my experience working with Firebase, it supports the real-time data transferring and notification from the box. So next, please. Great talk. It has been the one I've been looking for the most. Thanks a lot. My question, have you tried implementing MVVM pattern with GraphQL? No, I didn't. Next one. What would be the best state management to use with GraphQL? Currently, I used the block and GraphQL, as far as it has its internal caching mechanism, it serves some kind of implementation of its state management. So it serves you data either from cache or from network. So in my repo that I promoted, there is a sample how to work, how it is possible to work with GraphQL and block library. Next, please. Is it compatible with the Parse SDK? What exactly compatible with Parse SDK? And I didn't work with Parse SDK, sorry. Next, please. What have been some for hardest or problems you have run into when using GraphQL and how to overcome them? The problems or the hardest was to contribute in Artemis library. I made 2 big pull requests, one to support required fields and the other to move from the GraphQL JSON schema representation and parsing to the SDL parsing. So it was the hardest way to help make it more human-friendly. Thanks. Great talk. The GraphQL package, GraphQL Flutter, is only maintained by a handful of developers. Is it good enough for production? Yeah, you can use it in production, but you need to be ready internally that you will need to contribute or maybe donate or maybe fix or maybe fork and fix just for your needs the items. So I can recommend to use, but in some cases there could be an issues as with all library. And hit the star please on this repo and maybe on some issues because the developers slowed down a little bit currently in the package development. Next, please. How to convince backend dev to GraphQL? A lot of work is in fact done by the way the resolvers are implemented performance-wise. So, how to convince backends? Maybe you can challenge them. Maybe you can apply some soft skills. Maybe you need to convince not backends, but your manager. If you see that GraphQL gives you a better performance in terms of code writing, a better code writing experience, less errors, you maybe just need to talk not only to your backend guys, because as I mentioned earlier, GraphQL challenges a little bit of the backend. So just apply your soft skills and be aware to use GraphQL only if you definitely need it, not by the hype-driven development. Next, please. Or what is the timeline for getting this package of GraphQL Flutter to work with Flutter Web? Right now, it's just Flutter Android and iOS. If you check the GraphQL Flutter repository, there was among the latest merge requests and was merged into master the demos about working with, but the Pokemon example I assume works with the in the web. There are also among the issues there is this quick solution. So the only problem currently is the implementation of caching mechanism. So if you dig through the issues and examples, you will find the easy way how to make the GraphQL Flutter work with web. Otherwise, you can contact me through social networks or GitHub, and I will help you with the link. Next, please. Isn't the code generation is too long during developer cycle? As you know from your career of developer, I assume there is always the room for improvements. So the performance is one that we need to improve. You can help us with pull request. Next, please. Who is maintaining the Dart package? Is the Facebook or community driven? The Dart package for GraphQL is community driven. Next, please. Can we have a server implemented in C# and client in Dart Flutter easily? Just take what you have for GraphQL. GraphQL have servers on every language, from, I assume, from Rust to JavaScript. So easily, yeah, there's not big problems. Next, please. Did you try the Fairy GraphQL Dart library? I'm watching on this library. It is some kind of tries to be all-in-one solution. It supports the code generation out of the box, but nowadays I do not have much time to try it. But every several weeks I visit the pub dev and check how it goes. Next, please. What is the relation between Hasura and GraphQL? I didn't work with Hasura. So that's all. Thank you for your attention.